Okay, so I think I'm audible, right? Just a moment. Some technical glitches are there, guys. We'll sort it out right away. Okay, so good morning to everyone here. So I'm Vishal SK, founder and CEO of GalaxyZ Space, and I welcome you all to the live stream of Axiom Spaces and SpaceX together in collaboration with NASA for their Axiom 4 launch. So first off, we'll start with we have another 9 more minutes for the launch. So good to go for launch. So we'll just explain the process behind the launch. Just a sec. Okay. So yeah, all good. So we'll just walk through the process of the Axiom Space on what this particular mission is for and the astronauts involved behind and what are the sequences of stages that is involved in the rocket launch of the Falcon 9 rocket by the SpaceX and what are its pros and cons between and then along with the live streaming of the launch. So without any further ado, let's begin right away. So yeah, uh, so Axiom 4, it is a mission where it is stands for realize the return. So wherein which means India, Poland, and Hungary. So all these three nations together haven't gone to space with the help of government sponsored for more than 40 years. But in this particular scenario, Axiom 4 marks these countries for second human spaceflight mission in history. So it will be the first time for all these three nations to step inside the International Space Station. So this is the most ambitious mission for all these three nations, which is India, Poland, and Hungary. So this is a historic mission, and how Axiom Space is redefining a path to the low Earth orbit and elevating its national space programs globally. So this is also can be considered as a pathway or a gateway towards the commercial spaceflight or space tourism in the near future. So the launch is expected to happen around 2:31, the international standard timing. But then when it comes to India, we have the time limits, and so it is set as 12:01 p.m. So that is the timeline for the launch. And after some time, the duration of this particular mission, is expected to be for 14 days, and the system would be rocking around it takes around 1 day for the system to go to the international space station, approximately to the international space station, and the docking takes place over there. So that is how this mission works. And the astronauts behind this particular Axiom 4 mission is Peggy Whitson. She is the commander of this particular mission. Then we have the Indian Subhanshu Shukla, who is the pilot of this particular mission, who would be piloting the Dragon capsule. And then thereafter, we have a mission specialist whose name is Lavos Uzanski, and followed by Tibor Kapu, who is again a mission specialist. So we have an American, Indian, Poland, and a Hungarian. So here the highlight of Peggy Whitson is she is the commander of the space flight, and she has already been to space more very most often, and she holds a record that she is the American astronaut and sorry, among the American astronaut, she is the one who has spent most time in space, which is approximately 675 days. So she is the first female commander of the International Space Station and the only woman to serve as the ISS commander twice. And now she is the first woman to command a private space mission, which is Axiom 2. So Axiom 4 is the mission which is currently going on ahead, and Axiom 2 is the previous mission towards it. And the first woman and the first non-military chief of NASA's astronaut office and the first ISS science officer. So she is holding many records, and her astronaut number holds to be 429, and the time in space which she has spent is 675 days and 4 hours and 5 minutes, and still counting by this mission. Then we have Subhanshu Shukla, who is an Indian, and it is his debut flight, and he was a he is the pilot of this particular Axiom 4 mission. So then we have the other two from Hungary and Poland. So he is from Poland, and this his name is Lawanzo Usnaski. So forgive my pronunciation. So that is a bit weird, his name. And then we have Tibor Kapu, who is from Hungary again. So they do not have any flying records. So similar to Subhanshu Shukla, they are also newbies to the space flight. So the most important part here to be considered is this Axiom 4 mission will be India's second national astronaut to go to space since 1984, followed by Rakesh Sharma. So then here for the European Space Agency, project astronaut who is Sloan was Usnaski will be the second Polish astronaut since 1978. Then we have Tibor Kapu will be he is again the second national Hungarian astronaut since 1980. So it is all the three nations second attempt to go to the space, and as well as to the first time to the International Space Station. Here Peggy Whitson will be the commander for her second commercial space flight, same with respect to SpaceX, and adding to her standing record of the longest cumulative time, which we have mentioned before, which is of 675 days, right? Then Axiom 4 will be the second commercial spaceflight I have mentioned before, and this stands for the beacon of opportunity for India, Poland, and Hungary for the second time going for humanity for space, along with the first time entering the International Space Station. So now let's go to the rocket launch live streaming, so that you guys would be getting an awareness of it, and then we'll further take the applications on how things goes on. So yes, we'll proceed.
Just a couple degrees away.
And with that, we are just about 30 seconds away from the expected call out that LOX load has been completed on board our first stage.
So here again we have a series of sets or during
As we mentioned
prior
earlier,
to the
that
launch
mist
and
forming around the
post-launch.
outside
So
of
we
Falcon
can
9 is
split
totally
the
normal.
sequences like
That's just some of that.
Stage 1, LOX load complete.
Some of that liquid oxygen that has now been fully loaded on board to stage 1, venting out into the warm Florida air and condensing into clouds.
So we have another 1 more minute we can spend. So I'll just brief you down about the processes involved. So here, prior to 45 minutes of the launch, we would be having whether the launch is present or not, like whether we are good to go for the launch or not. Then in the 40 minus 42 minutes, with the crew access arm, wherein the astronauts walk to the launch vehicle, and then that particular pathway will be right. So in that particular pathway will be retracted from the launch vehicle once the astronauts are boarded the spacecraft, which is in our case here it's the Dragon capsule. Then followed by that we have the Dragon's launch escape system arm. So in case any issues will be if it is there beneath the boosters, like beneath the Dragon capsule, the astronaut's life has to be saved, right? So for that particular condition, this escape system will be armed, so that in any tragedy, that particular thing will be helping in order to escape. Then we have T minus 35 seconds, 35 minutes. We have the kerosene or the rocket grade kerosene, which is RP1, loading begins into the launch system. Then we have the first stage and second stage where the liquid oxygen loading begins for propelling the rocket system. And the mission was delayed due to the leak found in the liquid oxygen tank, and that's why it took around 15 to 20 days to rectify this, and we are now good to go for launch. Then the Falcon 9 begins to engine chill prior to the launch. Then we have the Dragon transition to the internal power. Then finally we have the command flight computer taking over the control countdown, and then thereafter we have the propellant tank pressurization for the flight beginning. Then we have SpaceX director verifies to go for a launch. Last 30 seconds will be last 45 seconds would be there whether we are good to go for launch or not. Then the engine controller commands will ignition before 3 seconds, and then the Falcon 9 will be good to go for launch. So now we shall cover the things, and then we'll discuss further.
Dragon, SpaceX, go for launch. Ax-4 is go for launch.
That is great news for mission control and
Yes,
from our
so
crew on
now
board
it's
Dragon.
go for launch.
With that,
So
we
as
are
I
just at
mentioned,
T-minus 30
T-minus
seconds.
30 seconds.
Okay, so we have last
To lift off of
26
Ax-4.
seconds. Finally, after 20 days, the mission is going to take place.
Let's
So this
go
was because of the
Ax-4.
liquid oxygen leak, which I have mentioned before. So finally, they have rectified. The team of SpaceX and
15
NASA,
seconds.
along with Axiom Space, has rectified, and now we are good to go. 10,
T-minus
9,
10,
8,
9,
7,
7,
6,
6,
5, 4,
4,
3,
3,
2,
2,
1,
1,
and lift off.
ignition,
So
and
again
lift
here, India, Hungary, Poland are again going to space for the
For
second
three
time.
nations, a
with
new
lots
chapter
of
in
hope,
space takes
for the
flight.
future space
Godspeed,
coming
Ax-4.
up. And then, yes, for the space tourism, this will be helping our space tourism in a wide manner or wide range of manner. So again, we have other companies like Honda and like producing the reusable
T
rocket
plus 30
vehicles,
seconds into flight
reusable
with the
vehicles
Axiom
for
4
India
crew on
and
board
other
Dragon,
countries.
headed to
So
the
that is
International
again
Space
a major
Station.
leap. So yes,
Waiting
so
to
now
hear
we shall
callouts
follow.
from the Falcon 9
So
engineering
here,
team.
max Q is given right.
Power
So
to
over
Ronaldo.
here. So max Q is a place where the rocket
We're
or the
throttling
launch
down the
vehicle.
9 Merlin engines. We're into the throttle bucket, preparing for max Q.
So max Q is a position or a place where the rocket
Max
or
Q.
the launch vehicle will be experiencing more aerodynamic pressure in that particular stage. So
Vehicle is
once
supersonic.
the max Q is completed, the atmospheric pressure will start to decrease, and the
We
rocket
should begin
will be
throttling the
stable.
Merlin engines back up now.
So here, as again said, we
Stage one
have
throttle.
the SpaceX's Falcon 9. So now the Falcon 9 is entering to the
Mission
max Q.
control confirming
Stage 1 Bravo.
that throttle up, and we
Copy
are
1 Bravo.
hearing our commander Peggy Whitson call out the first abort mode. Each of these are a specific phase where if for any reason we had an in-flight
Impact
abort,
show underway.
Dragon would abort to a safe location. So we're going to call out each of those milestones as we pass through them. We also just heard the call out for MVAC chill. We're going to trickle just a little bit of liquid oxygen now into the turbo pumps on board our Merlin vacuum engine on stage 2 in preparation for second engine start 1, which will of course be shortly after stage separation.
So here, in this particular scenario, the mission has completed the max Q. So it has passed the max Q stage, and then we have the stage separation, which is the first. So since Falcon 9 is a two-stage rocket, so the first stage will be out of fuel, and that particular stage will be removed from the rocket, right? So that particular stage separation will be occurring, and then we have the second MECO. MECO is nothing but the main engine cutoff. SECO followed by a SECO, which is the second engine cutoff. So this is the MECO. So main engine has been cut off and the stage has been separated. So this is the stage separation, and now the second engine will be starting its way to the low Earth orbit. So after that, we'll be having a SECO, which is nothing but the second engine cutoff. Here, the most highlighted part over with respect to the SpaceX is the booster, which is the main engine, will be again returning to the Earth for its reusable purpose. So here we can see the fumes and the altitude which the stage 2 is traveling along with its speed. So after some time, around 2 to 3 minutes, we will be getting the rocket or the first booster to be landed, whether in the drone or their ship, or else in their land. So most probably it would be in their drone ship. So they have a lot of ships called, of course, I Still Love You. Then we have one more, so two more, three ships are there. So either of the ship will be holding off this particular main engine, and then we will be having the entry burn for the orbit, for the main engine, followed by the landing burn for completely slowing down the first stage of the rocket. So as we can see towards the left, we have the stage 1, and towards the right, stage 2. So stage 1's speed will be automatically decreasing along with its altitude, and finally towards the end it would be increasing due to the drag of the atmosphere. And here we can see the crew now. So all the 4 crews are good to go. So they are happy. So it takes around 1 complete day to dock to the International Space Station. So that is again a tedious part when it comes to the space technology. And in case of stage two, we have in stage two we have the Dragon capsule docked in again, attached to it. So once the stage two's fuel runs out, we would be getting the SECO, which is the second engine cutoff, as I've mentioned, and then after that we would be good to go for the coasting phase of the Dragon capsule, and then from thereafter we will be doing a series of maneuvers where we would be having a series of maneuvers in the sense for the from the low Earth orbit it has to reach the orbit wherein the International Space Station is revolving around the Earth, right? So that is around 350 kilometers above the surface of the Earth, and then in order to enter that particular region or the altitude, a series of burns would be followed by the Dragon capsule once it has been separated from the uh, Dragon, the second stage. So as I've mentioned over here, okay, just a moment. As I've mentioned, here we have the SpaceX's post launch system. So we have the launch again, the rocket ascends, which is its current phase, and then the stage separation will be there. So following that stage separation, we would be having the coasting part, whether the second part, the first main engine after it's cut off would be coasting back to the Earth, and then we would be having an entry burn which is followed currently. Then we will be having the aerodynamic guidance using the grid fins, and then the vertical landing takes place, and the booster lands in the landing zone. Okay, we have some time for entry burn, so we'll focus upon the entry burn initially now.
Get back
Okay,
in
so we
the
got
atmosphere.
call that stage
And
one
now
entry
here
burn started
is
currently.
entry burn call out. This is going to be about a 12
So we do
second
not have
burn.
any visuals
That's going to
currently.
slow
So
the
total
vehicle
of
down.
9
You can
burns
watch
there,
that.
and then, yeah, we got the entry burn
There you just saw on the left-hand side of your
visualization towards
screen
the
that
left,
first
and the
stage
second
entry burn
image
shut
towards
down.
the right, second video stream towards the right is the
Right now on your
second
screen, we've
stage
got
of the
great
engine.
views of our second
So
stage
some
and take our
delays in
Ax-4
the
crew to orbit.
GPS transition.
The
So
next
we can see
milestone
towards
for
the
our
left,
first
the
stage is
one's
going to be the
altitude and
landing
speed is
burn, where we'll
decreasing
relight
currently
just
because
the
of
center
entry
engine,
burn.
as John
And
mentioned.
towards the
Dragon,
end,
SpaceX,
we'll be getting
nominal
the landing
trajectory.
burn, and
Again, things
we'll
we love
be-
to hear.
Stage one
again,
FTS.
Dragon
will it be a
copy,
successful
nominal
landing for
trajectory.
SpaceX or not? Let's wait and watch.
Continuing to get good communication from our crew on board Dragon.
Stage one transonic.
Yes, so the
Confirmation that stage one is now transonic on its way back to LZ1, which is
The
just
speed
about
has
9 miles away from our
dramatically
liftoff
or
location today.
drastically. So see the
LZ1, of
difference
course, is the
between
site
the
of the
stage one
first
speed and the
successful
stage two
landing
speed over
attempt,
here.
and hopefully it will be
It's
the
like 16
second
times
time that this
difference.
particular booster sticks its
Okay.
landing.
So now the landing burn has started, and again we have the drone ship waiting over there for
Seeing
the
those actuating of the grid fins that John mentioned.
Stage
Yes.
one landing leg deploy.
So the landing leg has
Stage
been
two
deployed. So
FTS
it's not a
is
ship, so it is again a terrestrial landing. So yes, it is a successful
Stage one
for
landing
SpaceX.
confirmed.
That was a picture-perfect landing. That was great.
Absolutely stunning.
Congratulations SpaceX for a perfect landing of the booster. So now we have after the landing burn, now we have the
So
second
coming up
engine
next
cutoff.
for our crew, now that we've confirmed that booster touchdown
And
is
then
going
the
to be
Dragon
second engine
separation. So with
cutoff,
that,
also called out
we'll
as
be
SECO.
concluding
Then the second stage will coast
session
for a
on
few
the live
minutes
stream.
until Dragon
Follow
is
that,
commanded
we
to
have
separate
another,
from the second
1 day
stage.
for taking place for the docking process.
There's
So
our
we'll
Ax-4
try
crew
covering that if
awaiting that
possible.
SECO call out
So
here.
this is the major sequences that has to be taken care of, and now
Stage
the
two is
system
terminal
and
guidance.
The astronauts are in orbit. So as I've mentioned, there will be a flip maneuver, then the booster back turn. So the grid fins will be deployed and
Good
guiding
continued
that
burn
to
from
the,
our second stage engine there. Now, at this point, our
terrestrial
crew
landing,
is
and then
experiencing
we'll be
about
having the
3
landing.
Gs in the lead up to
So
SECO 1,
then,
which, of course, will
now,
be
after
their
the
first
SECO,
taste
which
of
is
microgravity.
second
SpaceX
engine
Dragon,
cutoff.
Shannon.
Yeah. So after the second engine cutoff, we would be having the Dragon capsule separation, and then the Dragon further will be taking its path towards the space station, International Space Station, making India, Poland, Hungary the second time and into the space, and first time into the space station. So these are all great achievements followed by this particular Axiom 4 mission. So as mentioned here, the second stage engine. So yeah, that's what. As mentioned earlier, we would be getting the yes. So we can visualize the second engine cutoff, and the Dragon capsule has been separated successfully. Kudos to the SpaceX and Axiom Space along with NASA. So now the next station we have is International Space Station.
नमस्कार मेरे प्यारे देशवासियों बहुत भाई 40 साल बाद हम वापस अंतरिक्ष में पहुंच गए हैं और कमाल की गाड़ी थी जिस समय हम 7.5 किलोमीटर प्रति सेकंड की रफ्तार से पृथ्वी के चंद्र से
Okay. So yeah, that is all which we wanted to cover, and that is what Axiom 4 mission is all of. So now the crew will be going towards the International Space Station. So this takes around 1 day, 24 hours approximately. So it depends upon where the space station is and how successful the maneuvers are. So then followed by that, we would be having the Dragon nose cone open sequence, wherein the nose cone is designed for the optimized aerodynamic efficiency. So that particular cone would be removed in the space, and then the docking latches will be enabled in order and dock accordingly. So this is what I wanted to convey. And as we have mentioned, so this is the takeoff or the launch pad of the rocket, and then followed by going into the low Earth orbit. From there on, we would be initiating certain boosters or maneuvers in order to reach the International Space Station nearby. And then from there on, we would be getting the thrusters burn, and then towards the final co-elliptic, which is a phase in which over here it is the approach initiation, wherein the Dragon establishes a communication link with the International Space Station and performs the final orbit and performance and controlling its delta V, so which is the velocity. And then we have the proximity operation, wherein the Dragon establishes the relative navigation aid to the International Space Station, arriving along the docking axis, initiating an autonomous approach, followed by the docking and pressurization, which is the sixth phase. Once the docking or the Dragon capsule is near to the International Space Station, we would be getting a sequence of docking enabling, and then for the proper pressurization or the oxygen inside the space station and inside the Axiom Dragon capsule, proper pressurization will be taking place, and that is how the the doors of the International Space Station will open for all the 4 astronauts on board the system. So yes, with this we would conclude this live stream. Hope everyone has got a particular idea on what this particular Axiom Space mission is for, and we would be continuing, or we would cover the future space missions shortly, and will be giving in a detailed manner on what that particular mission is for, and we would wind this session. So follow GalaxyZSpace for more live stream, for more videos, for more information on space and on technology. So follow GalaxyZSpace. Do subscribe to our YouTube channel. Follow our follow our social media handles: LinkedIn, Instagram, X, YouTube. So wherever possible, and keep a look, so that we would be having interesting sessions which are upcoming along with our website. So, Godspeed, goodbye, take care, see you.